right. Main. Hello everyone, welcome to an AddOhms live stream. Today is June 6th, 2018. So if you're watching this and it is not Sunday, June 6th, 2018, then this is not live. I feel the need to say that because based on the comments, I don't think everybody understands that a archive live stream is no longer live. Anyway, my name is James. I'm the Bald Engineer. For this live stream, I'm actually going to be working on a project. And so normally when I do live streams, I sort of have like a topic and plan for what I want to go through. On this one, I'm actually going to be designing something. So what are we going to be designing? Let me show you here on my computer. Oh, before I get into that, just something, and I'll try to repeat this throughout the stream. So I am multi-streaming, meaning that this is both on YouTube and on Twitch. Twitch I might use more for a less polished, in fact, more like what I'm going to do today, less polished stream. There are 3 places that chat is happening. So there's the YouTube chat, there's the Twitch chat, which I don't think anyone follows me there yet, so probably not much going on. And there's a Discord server that I've got set up for AddOhms. And so on screen, you'll actually see all those chats combined into one location. Okay. All right. So what are we doing, or what am I going to be doing today? I'm going to be doing no signal. That's not right. That should have been, there we go. All right, get this turned on now. So Maker Faire is coming up. Bay Area Maker Faire is coming up in a couple of weeks, and I got to thinking I'd like to have a unique name badge, and so my initial plan was to use a vacuum fluorescent display, a VFD, and so that's what this guy is. And so this is like the alphanumeric displays out of, say, like a microwave or something. And I got it at the surplus store that's here in the Bay Area. It was like $4. But what I didn't realize is all of the ones that store has are blown. And so, in fact, if you just sort of look, there's like a circle over here. I didn't notice this until I got them home. I bought a couple. But they've all been blown, and I think what has happened is they've been damaged by somebody applied too much voltage or reverse voltage to the grid. And so the way that these work is that they're almost like an LED in that there's an anode and cathode where electrons get emitted, but then you apply a grid voltage, and when the electrons come in contact with the grid, then they actually illuminate. And so these aren't able to illuminate. But it did give me an idea. Why not use something alphanumeric? Because, that's kind of a retro look and it's kind of cool. But the thing is, I didn't want to go and just buy brand new parts to make the display. And so I got to thinking, what could I do? And my initial thought, my initial thought was this. I was actually going to try to design one from scratch. And I even bought some of these through-hole LED. Laptop main. I even bought some of these through-hole LEDs, but turns out a couple of things I didn't realize. So first, I was going to try to do it with all the same size LEDs, and that doesn't look right. And then I thought maybe I could get a couple different sizes or 2 sizes, and that still didn't look right. And then when I looked closer to the digits, I realized, oh, these are actually it's not as symmetric as I thought, and there's also a 10-degree tilt. And so I was like, okay, well, that's kind of a bummer. So then I got to thinking, well, what else could I do? Again, I didn't want to necessarily go and buy parts. Like, say, if I go look on DigiKey right now, they sell LED alphanumeric displays for like $3. And I mean, that's not, well, actually that's really expensive because I want enough digits to say Bald Engineer. And so I need at least 12. And so that didn't really get me too excited. So I just typed in alphanumeric LED to get an idea for maybe somebody else has already done their own design. And then I saw this. Jameco, which is just down the road from where I'm at, like literally like 10 minutes away from my house, they have some on clearance, and they're dual character for $1. So I decided I'll bend my, I didn't want to use brand new parts rule just a little bit because these are on clearance and they're cheap. The only thing I'm not excited about, well, there's actually two things I'm not excited about, is that they're red, which means I have to drive them really hard to make them bright because red LEDs are already dim and our eyes don't see red as nearly as well as it sees green. And I really want it green, but for $1, I'm not going to complain. And then the other thing is that the digits are, based on this drawing, are about the same size as these, which on a VFD, which is very, very bright, I think that's going to be really easy to see. I'm a little bit worried that digits this size on LEDs are going to be kind of small, because I'm imagining like I'm going to clip it onto my badge and have my name. And so I'm not sure if it's going to be easy to see. So I went and did this mock-up, and this is when I realized, here we go. So this is, I want to say this was like 110 millimeter, no, yeah, 110 millimeters in size, which is roughly 4 inches, right around 4 inches. And so it's actually not going to be too far off from what I've got already. Then I went to the next size up and realized the thing was going to be 8 inches long. And what is that? 8 by 2.5. So it's 160, 200 millimeter. Yeah, 200 millimeters wide. And so that would have been like something like this. And so I'm not really sure I want to carry around LEDs like that. Okay, so that's what I've got going on, is I want to design this alphanumeric badge. And so what we're going to do is I'm going to head over to KiCad, which we learned recently is the actual name. It's, well, I say actual name, it's what one of the project maintainers calls it. So I say it's the actual name. And we're going to start designing this guy out. So that's what I'm going to be doing on this stream. Feel free to ask questions, electronics questions, questions about the project, questions about AddOhms, Bald Engineer, whatever. Part of why I'm doing this live is so that I have somebody to talk to while I work on this badge. So first thing, we're going to get a schematic going. And then I will shrink this down so that you guys can see it. We'll try to work inside of there. All right. Okay, wait a minute. Shoot. This mouse is not set up for this computer. Later, I want button 4. Yeah, okay, there it goes. That's weird. Oh, I know why. Yeah, okay. Thanks for the offer, Paul. Turns out I've already placed the order, and so I'm going to go pick them up tomorrow. All right. So, what did I was also going to just kind of go through this. So here's what I thought this might be a good way to, this is what we're going to go through. So I'm going to have the 6 2-digit displays. Each are going to get their own BJT. What I'm going to do is drive them from the, I'm going to make them a common anode. There'll be I need to have some form of power switch, and based on the current block diagram, I think I'll have enough room for buttons to do dimming. And the way that I'm going to drive them is actually through a TLC 5490 or 5940. I want to use that one because it's a constant current sync. It's 16-bit, it's PWM, and it's a single chip. So I'll be able to drive 1 digit from the TLC, and then using the transistors, I'll multiplex them. And so it'll make wiring and programming super easy. I'm going to use two AA's for the power source. I'm going to put them in series. And so what I've actually drawn in the block diagram, so here's the digits, and then here's what the two battery holders will look like, which will overall form the actual design. Let's move this over. All right, and then let's see, boost converter. So I almost overlooked this. So I could use AA lithium cell batteries, which have like roughly 3,000 milliamp hours of energy. But there's milliamp hours power. Anyway, but I don't really want to burn through a bunch of expensive batteries, and I couldn't use a lithium polymer because the size of that is huge compared to the rest. I mean, this thing would have just dominated the size of the package, and so I ended up thinking AA's, and then I didn't want to use lithium cells even though they have a lot of energy, so I decided to use rechargeables because I've got a ton of rechargeables, like for my mic and a couple of other things. But they only put out, what, 1.3 or so volts when they're fully charged. So that's going to be a little bit low even for a, that's going to be a little bit low. So I decided I'll build a small boost converter for the logic and then drive the LEDs directly from the batteries. Solder jumpers so that I can disable the boost converter just in case I screw up the design. Since I've only got 2 weeks, it's going to take at least 5 days for OSHPark to get the boards back to me. And then I'm going to break out all of the signals so that if all else fails, I can just use the board that I designed as a display. And then, of course, mounting holes. And then this just notes for the AT Mega. Please sound more louder. Yeah, I don't know that I can make the mic any louder. Sorry. This is the normal volume I use, and it's usually not an issue. Let me bump this up. That's about as much as I can bump it up. Let me just double. Yeah, that's as good as I can do the sound. Okay. Let's go and take a look at okay, so enough of the kind of setup. I really want to actually get started doing something. So I'm going to start with the AT Mega circuit because that's the easiest thing for me to do. 328. Now, if you remember, I did do the DIY Arduino series. So there's the schematic episode, which is like episode 23, and then the PCB, and that's where I was making the Pyramid Arduino, which I've got the boards back, I've got the parts. In fact, I'll be working on that video after this live stream. Part of the reason why I'm using KiCad today instead of, say, like Eagle, which I checked out last week live, is I only have a couple of hours to get this worked out, and I really want to get the board to OSHPark today so that it starts the batch, so it gets into the batch tomorrow, or gets into the batch tomorrow. All right, so I just don't want to mess around with something that I'm not as familiar with. So I'm just going to add a bunch of caps. We'll use them all in a minute. Let's get a couple of resistors going. Yep. Yeah, there's two reasons why I'm using the 328 on this one. One is like Shanu said, it's easy. The other one is because of the Pyramid Arduino project, I have a couple extras left over, so I can salvage, not salvage, it's new. Steal. I'll steal a new one. And on this particular project, all I wanted to be able to do is display like Bald Engineer, my name, and then maybe like a couple of words. So I don't really need like USB or anything like that. So, okay. Now let's go ahead and get, now I need power, G&D, and go ahead and put that over here, and then put a couple more. Okay. All right. So what's funny is right now I'm really missing, in the newer versions of Eagle, they have a design block thing where you can actually plop down an entire design block. I could really use one of those right now, but whatever. All right, so I know I'm going to need these signals. And then I'm trying to think on, I'll have to go look at the chip later. But for now, I'm just going to pick, let's see, we need, I want to have, nope, that's not going to work. I want to have, all right, button 1. And button 2. So I'm picturing 2 push buttons so that I can increase or decrease the brightness, which will be done through PWM. And let's chip select. Let's just copy these. So this is going to be both the in-circuit serial programmer, and it's going to be the SPI connection to my TLC 5940 chip. Now, the reason I'm actually kind of doing this one chip at a time is I just want to be thinking about what do I need as I go along. So that's what I'm thinking there. The power supply. Actually, if you stick around, I am going to try making the switch supply in this video, the boost converter in this video. And so we'll see how that goes. I'm not sure how far I'm going to get before I cut the stream, which I'm sort of wishing I had done this last night, but oh well. All right, let's go ahead. So this one's I am gonna make a node for VCC, which is gonna get connected to, oh, what? I like the little arrow. V-bus, that's not going to work. Fine, we'll use the bummer. All right. Okay, move. Analog, why not? I'm not going to be using it. AREF, I'm not going to worry about. I'll have a surface mount part, so I'll have 6 and 7. Okay. All right, I forgot to label these. Okay, so this is a thing that gets a lot of people. So I'm going to put an FTDI header or a serial header on the board. And so I need to make sure when I do that, that transmit and receive gets swapped. So I like to call it 328 receive and 328 transmit. And that way I can keep the direction of the serial signals straight. All right, now I'm going to move this one up here. And we're going to totally cheat. And I'm going to try and get away with just a 10 microfarad capacitor. Footprint I'll come back to, and then I did this. I'm going to come back to that. Do you want to remove? No. What? Do you wish to remove this and all remaining undefined fields? No. 106K, 9 PAC. All right. Use the LDR to measure the ambient brightness. No, not for this design. I did think about that, and the only reason I decided not to is just time. I don't have any form of light sensor, and so yeah, I did think about that. I thought, man, it'd be a lot easier if I could just not have to worry about the. Wait a minute. Where's reset? Oh, okay. Wire. That's weird. Reset. So what we're going to do. This is going to be a 100K. Nice, nice pull-up. Of course, I just did the video on pull-ups, and 100K I would say is a weak pull-up, but it's going to work just fine for us. All right, I'm going to move this one and wire this, copy a label, DTR. So this way I can have a nice auto reset copy this, not move. All right, let's save that. Edit. This is going to be a 100 nanofarad, and I'll get the values later. All right, 100K, 100. I'm going to try to get away with one decoupling capacitor. Now, unlike what I did in the DIY Arduino video, this one I'm going to leave the crystals disconnected. I'm going to use the internal oscillator. All I'm going to be doing is driving some LEDs, so timing's not all that critical. Which, yeah, what I'm actually thinking about now is, if I use the internal oscillator, will I be able to program over serial anyway? Because with the internal oscillator, the timing might be off. Well, I'll leave the reset circuit. If I run out of room, then that's going to go. Okay. Okay. And then one more thing I want for my logic stuff, because I do tend to forget this sometimes. Let's go ahead and just move this up here. Add LED. Now, this isn't going to stay in the circuit, but it's really helpful when you first turn on a board to have something turn on. So we'll use this. Okay. All right. I think that's all I need to get the 328 going. If anyone sees anything I'm missing, let me know in the chat. Okay, 328 mega. You know what I'm going to do? For the moment, we're just going to so let's see, ADC, so that's A2. The thought I just had was, just in case I have room on the PCB, why not have a few extra I/O pins broken out? Who knows how I could use them. And I'm sticking to the analog I/O pins just because then I can use the analog, the A to D. Even though I'm not going to connect AREF, it'll connect through VCC. I'm not going to do a complicated decoupling here because I'm not going for anything instrument grade here. So I think we'll go with this and see how that works out. Okay. Okay, so we've got that taken care of. Let's go ahead and add an MO6. And then what I need is the FTI pinout. And you guys won't be able to see this, but that's okay. I'm just looking for basically this. All right. Wire. Clean up that one in just a second. Let's see. So this is going to be CTS, which nobody cares about. Edit. Now it's actually RTS, but I just need that signal connected to the reset for the auto reset, so that's all I care about there. This needs to be 328 transmit, and this is 328 receive. This one's going to be VCC. I'm going to delete this and wire this over here and copy this to make this. So, hey, real quick, I was going to do a whole video on KiCad or KiCad usage tips, and instead, I probably won't get to that in the near future. I just went through a schedule, and I've got a bunch of stuff that I want to do first. So one thing I'm going to mention is especially if you're using a laptop, get an external mouse, because being able to use the scroll wheel or middle button to pan is a huge help. And then I have this gaming mouse, which I mentioned, I think, in the last stream, which has these 12 buttons on the side that you can do with your thumb. And so in almost every design tool I use, I've mapped these buttons to common functions. And then I've done things like, for example, 10 and 11, I almost always map that to zoom in and zoom out, so that whatever program I'm using, whatever hotkeys it uses, then that works. And so, and then I do things like, I might do like enter or backspace or commonly used keys. Now, so big help there. But the big thing I was just going to say is, if you're doing KiCad stuff, I really recommend using an external mouse. I love Macs. Their touchpads are great, but they're not good when you're trying to do like 3-button type operations. And on PCs, most PC trackpads, I find them usable to browse the web, but not draw schematics. So just a quick thought: get a mouse. It makes things easier. You know, like for example, panning with the middle button is just much easier than trying to, do it any other way. So okay, all right. Yeah, in terms of, I'm not going to actually do a mouse review. I will tell you this is a Razer Naga, and while I love the mouse, their software is abysmally horrible. There's actually, might have saw me go into it earlier, there's actually utility on OS X by this guy in Japan that does an amazing job supporting the mouse. And I've got a gaming keyboard, which I use on my desktop, again, because it's got a bunch of macro keys. Why is it that all of these like tools that are all these things that are like programmable, they have the world's crappiest software? I don't get it. Oh man. Well, bummer. KiCad TLC 5940. Does anyone have a footprint for the 5940 already? I really do not want to create this from scratch. Or do I? No, I don't want to. So that might have it. So Texas should have it. Okay. Why didn't it show up in mine? Because I don't have Texas loaded. That would be why. Okay. So, what am I doing? I need to, nope. Symbol tables. Come on, come on, come on, come on. Texas, 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 RST. Okay, let's turn that one on. Add. All right, so basically what I was, sorry, I got lost in thought. So what I was doing is I was trying to find the 5940, which I thought was in KiCad, but it didn't show up. So I did a Google search, and then I noticed that in the main repository, it's showing up in this, it's actually showing up here. So I knew it had to be somewhere. Now that's a dip, and I'm going to be using the SOP version. So we'll go with this one, place this guy down. Links in Discord might not work. I just added a new bot and I haven't really configured it yet. So I think it's set to kill links. All right, so we're going to do this. This is also going to get powered by VCC. Oh, it's been a while since I used this guy. All right, well, let's get the signals I remember. So the TLC 5940, if you go look it up, if you're not familiar with it, it's sort of lived on in silicon form without the parallel outputs. NeoPixels have a very similar circuit built into them, just on a single channel basis. It's basically a constant current regulator. So voltage regulators like the LM7805 they regulate voltage. So whatever happens to the current coming out of them, they try to maintain a stable voltage. So the way that the 5940 works is it will actually try to maintain a constant current, and it's a current sink. So this works really well with common anode LEDs since you connect the cathode to it. And so instead of having a series limiting resistor, each one of these outputs will change its resistance effectively so that it maintains a constant current. And so this becomes a constant current driver. It's not a regulator, but it is a driver. It is a little bit confusing too because it sinks current, it doesn't drive current, but that's kind of just the way it is. So that's why I really like this chip. Now they claim it's only rated for like 120 milliamps total, but I've got a friend that's done a bunch of LED strips. Like on my bench, I've got LED strips lighting it up. He's got them all over his house. They're all driven by 5940s, and they're all like drawing like an amp or a couple amps. Yeah, maybe it's 1 amp per chip. And so even though it's supposed to only be rated for 120 milliamps, it seems to work fine. So pretty sure chip select's supposed to go somewhere. So what I'm going to end up doing, MI master in serial out, master out serial in. Keep doing that. All right, so SPI has, so if you didn't know, on SPI, serial peripheral interface, the SPI pins, so MOSI, M is master, S is slave, which is a very historic naming convention. Now it's more like host device for good reasons. But anyway, so this means master out, slave in, and master in, slave out. And so the idea is that, so I want the signal to go from the master device to the slave device. And then if I want it to chain this out, oh, I put that in the wrong place. So then this S out could go into the next 5940 as this would actually become the master out, slave in. So, but we don't need to connect that to anything. I'm only using one. All right. Blank, I think, is a active high. Let me try something. I have an old Eagle project that I did. And so we're going to see if Eagle will launch that. Yeah, that's what I'm talking about. All right. All right, for the chat, got a question for you. What was the first circuit board you ever designed on your own? Tell me what you designed first, and then I'll tell you about my first one. And if you, okay, let me extend that because I have to. What's the first circuit board you ever made? Whether you designed it yourself or maybe it was somebody else's design, but you actually fabricated the board, because that's my story. Why the MC chosen? I don't understand why the MC chosen. KiCad. What I'm trying to do, I need Eagle and KiCad. Now, you guys can't see my Eagle circuit, but that's okay. I'm going to be drawing in KiCad anyway. So vprogram doesn't connect anything. iref goes to a resist. I keep doing that by mistake. Now this goes to a resistor to ground, which I haven't calculated yet. This iref resistor is actually how you set the current for the outputs. And so there's a formula in the data sheet, but for purposes of this design, I just need a place on the board for the resistor. I'm going to add that later. Power supply, 8x8 LED matrix. Interesting. Yeah, actually, I think on a live stream, I'm going to do a special unboxing, speaking of power supplies as a first circuit board. So I graduated college in 2001. And when I did, blank needs a pull-up. Well, this is, who designed this? Oh, this is dumb. Okay, this is, who, okay, all right, this is dumb. So DC program and blank need to be pulled high, which iref is in the way. Normally, I would go and just edit the package and change it. This is how do I tell it to use? Okay, I don't like the way that the pins are laid out, so I'm just going to change them. I don't get why they did it this way. KiCad. Where's my library? Should have a folder called My Libraries. My Library. All right, and then I'm going to move this down here. Move this down here. I'm going to move this up here. All right. If I try to save that, I don't know where it saved it. I don't know where it saved it, and now I'm mad. Tools. Let me see something. Is 5940. Come on. Why is my library not loaded? It is. That's not showing up. So it must not have saved it into mine. That's okay, because at least, okay, it updated. So now iref is in a reasonable place. So now I can move this down here, wire this over here. So the story I was telling, the first power supply PCB I designed was in college. The project is, I still have it. It was I called it 10, T-E-N. It was the electronic notebook. It was a single board 386 with flash drive, connected to an LCD, connected to a digitizer. And so it ran Linux, and it had a program running Qt that allowed me to draw on it. And so I called it an electronic notebook. And so everything in it was off the shelf except the power supply. And it is the worst power supply design I've ever done in my life. And so I'm actually hoping the circuit's still in there, because it's comical how bad it is. All right, so this is going to go to DNC. As for 8x8 LED matrix, I think matrix is actually a really good circuit to like practice in terms of PCB making. I've wired a matrix by hand, and I've done PCB design, or I've done it on a PCB. And so I find soldering LEDs into a matrix PCB really therapeutic. It's kind of nice and fun. Man, I feel like this is supposed to go somewhere. Arduino TLC 5490, 5940. I feel like X latch is supposed to be connected. Hardware. Oh, gosh. All right. I'm going to connect it to pin 9. did I say DC program gets connected to, oh, shoot. I still did that wrong. Properties, library editor. Move this here. That is really weird. All right. Save. That should update. Blank DC program. Nope, still not yet. All right. Nope. DC program and blank. Okay. Interesting. So KiCad's not updating until you add the existing part to the schematic. I thought there was like an update thing. Transformer, diode, capacitor, stabilizer. Yeah, mine wasn't even that complicated. Although I like doing diode bridges. In fact, this is really dumb. I don't like when I open up an AC to DC supply and the diodes are like they're in a row where it's like, up, down, up, down. I like diodes laid out on the circuit board, just like you draw the schematic where it's goes like this way and this way to draw the rectifier. I don't know why. It just bothers me that, it's from a design perspective, it doesn't matter. I like to open it up and see like an AC socket and then a couple of diodes and then the transformer. Come on, why not? Or AC transformer, whatever. Yeah, so okay, so like I said, the project where I did the board, the reason it was so bad is we were hand etching them, and so we had to do like the whole laser printer transparency thing, and I didn't put any clearances around any of my mounting holes, or any of my through holes, and so I had to use like hot glue, I think, to keep the wires from shorting out to ground, and it was just a mess. I would like to think I've gotten a little bit better at, let's move this guy, at PCB design since then. Okay, so IREF V-blank's going to be a 10K. I don't think blank. For the moment, I am going to do this. I don't think I'm going to need it, but I'd like to have the option to control it. And then I'm going to say, let's move one of these. Oh, up here. Man, this schematic is getting to be a mess. Okay. And then we're just going to do this, do this, do this. Coupling capacitor for the 5940. I'm not doing the part numbers right now because I actually have a part number I'm going to end up using. So S clock, S in, S out. Okay, so we need to label these. Out 0. So these are going to get connected to each of the segments on the alphanumeric LEDs. And then the way that the matrix will work is each of the LEDs are going to get their own transistor, which is going to be super fun. Okay, now you're just irritating me. Whatever. 14, 13, 12. All right. Okay. And then PA, I have no idea what PA is. Oh, pad. Okay. So this, the TSOP package has a pad on the bottom side, which will need to get connected to ground. So I totally missed the D on that. Okay, so backing up or refreshing, if you're just now joining or it's been a while so you forgot what we're doing. So the Bay Area Maker Faire is coming up in about 2 weeks, and I thought it'd be cool to make a little badge that says my name, or at least says Bald Engineer. The original plan was to use this one of these like vacuum fluorescent displays that I got from a surplus store, but all of the displays that they have were burned out, and so can't really use this. But I like the idea of using like old school alphanumeric numbers or digits, and so I came across this from Jameco, which is just down the road, in fact the opposite direction of the surplus store, which is a 2-digit alphanumeric display. So I'm going to put 12 of these on a PCB with some batteries, a boost circuit, and an ATmega 328 so that I can display messages while I walk around Maker Faire. And so in this stream, I'm drawing the schematic, and then we'll see how much of the PCB I can get drawn. Ideally, I want to get this board done today so I can submit it to OSHPark and get it back by next weekend. So we've got the ATmega 328. We've got the TLC 5940. The TLC 5940 will drive the LED segments. Let me go back to my checklist. So, okay, so power switch. So this is going to be part of the power circuit, which I want to move down here. So 5940, this is actually, I'm not sure I want that yet. Transistor TLC points. Okay. All right, so let me think about that for a second. I might just skip that idea. Power switch, boost converter, I'll worry about that in a minute. Battery holder, worry about that in a minute. Buttons for dimming. Okay, let's add, that's an easy one. So push button, so this is going to be, I'm just going to put them like right here. Button 1, we'll call this switch 1. Oh, no. Call that up. And we'll call this one down. And then I'm going to rename this to be, we'll just do it this way. All right, I'll use internal pull resistors. So all I need to do is connect these to ground, and then we're good to go. All right, move this over. This is going to be button 1. This will be button 2. All right. All right, so we got that's done. That's done. Auto reset. Oh, reset button. Okay, let's go ahead and add one of those. I'll do that over here. Copy this. And just like my note says, if there's room, this is kind of to me, if the thing is, I'm probably going to end up, if I mean, the reset button is totally, at this point, is going to be a nice to have, because I'll probably end up just programming this over with a serial programmer anyway. I mean, once I'm walking around the show, it's not like I'm going to reprogram this thing. Can you tell which is plus or minus on LED if both sticks are the same length? Yeah, use multimeter. So, in fact, when I teach people, when I teach electronics classes, so when I teach electronics classes, one of the things I do is, so I used to teach a class on how to use multimeters, and one of the things I would do is purposely before class, I would cut the LEDs so that the positive was the longer LED, the longer lead. And that's for two reasons. One, the long lead as negative is not a standard, it's a convention. And I have bought LEDs where the long lead was the anode or the positive. So you can't just go by the length of the LED or the length of the lead anyway. Or was it the cathode? Whatever. It was backwards from the standard, from the convention. So even if I look at the LED, even if I see the flat spot on the top of the LED and I see the one that leads is the different length, I always double check with my multimeter, because the multimeter will only read in one direction, and that tells you which is the anode and cathode. Yeah, continuity test, LED. Tell you what, because it's super easy to do real quick. So let's do, now I haven't done anything with this LED yet. It's a green LED. I know the light makes it a little bit difficult to see, but if you look at the leads, it sort of looks like this one is shorter than this one, but they're pretty close. So what I'm going to do is take my multimeter, and if it has a diode setting, this makes it super easy, because then I can just take my leads and go negative, positive, and I see that the forward voltage is 1.7 volts, which for green LEDs tends to be about 1.8 volts. If I turn it around, it reads as an open. So what this tells me is so what this tells me is that, because this is my negative on my, this is my negative lead, this is the cathode, this is the anode, because when I connect them, I get a reading of the forward voltage. Really simple. Easy, easy, easy. Now, if you don't have a diode setting on your multimeter, then as somebody in the chat said, just use continuity. Continuity does the same thing. The only difference here is that you won't get the forward voltage. Instead, you'll probably see a resistance value. I don't know what these are rated at. That's weird. Huh. Okay. Maybe I guess the forward resistance is too high for this one to read as continuity, but you can see 100K or so resistance. Turn around, this should read an open. Fuck. I don't know what these are. Let me try something. I love getting sidetracked. Okay, turn this one around. Should be 1.6. Yeah, okay. Yeah, this is working how I would have expected. The other real cool thing is, this is what I was expecting on the ohm setting, on the resistance setting, is you'll actually see the LED will actually turn on. Now, red LEDs, you don't really see all that well. So that's 43K. I wonder if it's this meter's switching, because that's, anyway, that's how you do it. That's kind of bothering me. That didn't work the way I expected. Meter's not doing what I thought. Yeah. So on one of my previous jobs, all I ever did was demos. And it was always frustrating how often the demos wouldn't go right. I guess now that I think about it, I guess I almost never use continuity or resistance for LEDs. So it's not working the way I expect it. I just always use the diode setting. And what I sort of expect is red LEDs should be about 1.6. Yellow and green should be around 1.8. And then blue, usually with blue LEDs, hold on. Usually with blue LEDs, the forward voltage is blue and white are on the order of 3 volts. And so most multimeters only do diodes up to 2 volts. So what will happen is you won't get a reading on the meter, but you will get at least a, you'll at least see the LED light up. And so that's how you'll know which is the forward direction. And on blue, it's really, really bright. And so it's really simple to do that one. Same thing with surface mount. Usually with surface mount LEDs, if you tap the 2 leads, I just watch for them to light up. I don't even look at the meter. And that helps me find the anode and the cathode. Okay. I'm procrastinating because I'm basically getting down to the part where I have to do the really hard part, and I don't want to do it. That's going to be the alphanumeric displays. So that's why I'm procrastinating this. So we got my buttons. The battery holder, we'll do that later. Well, actually, what I'm going to do for that one, I'm just going to add a battery cell, and we'll just do this, and then we'll add a voltage node. What do I want? I want to name it myself. Oh, actually, that will work just fine. And then ground for that. So that's going to end up going into a power switching circuit. All right. I'll move these over here. Move this over down away. Okay. Now I'll just do that. I've got to design the package for that, but we'll get to that in a minute. Boost converter, switch. Actually, I know what I'm going to do for the battery. So the thing is with the battery, I'm going to kind of cheat because I'm using this. This is going to put 2 cells in line with each other, but I don't really want to. I guess actually this is the rectangle and 2 holes. Okay, I can draw that. That's not a big deal. We'll create a footprint for that in a minute. The boost converter, transistor, and test points, mounting holes. Oh, let me do the mounting holes right now while I'm thinking about it. So what I do on these, I just do like in pin headers and just go copy, 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 copy. And then I like to tie mine to ground. I don't know. Somebody might tell me that's a bad idea. I like to do it. If anything, it gives me a place to clip a scope probe to if I need it. Okay. All right. And then, yeah, just leave those as don't cares. That's done. So I got that. Transistor test points. What am I thinking now? I think I'm actually going to move this down here. Let's move this just over here for the moment. Okay. I want this space for my alphanumeric displays. Okay, save that. I wonder, what is the chance lattice logic? I was hoping EFG, HIJK, linear. Nope. I was hoping there's going to be a light on and maybe this thing's already in here and then I don't have to draw it, but I got a bad feeling about that. So what we're going to do is let's do KiCad. So why isn't this working? So why not use a LiPo or an 18650? The reason why is size. Where did my drawing go? The reason is size. So this is the total, I don't know what this is. Oh, that was another display I found. So I'm looking for the badge device to be about this size of the blue box. And so this is going to be the displays and then the 2 AA battery holders. And so that works really well. The problem is if I go with something about that size, oh, actually, you know what? This is where I drew it. I knew I had this drawn already. So if I go with something about this size, then it turns out like a 500 and a 2500 milliamp hour pack. They're just a little bit too big. It's like, where do I put it? How do I balance it? And so it's like, I'd rather have just the 2 AA's. The 500 fits pretty well, but with the LEDs and the calculation I did, it only lasts about an hour, and I don't want to carry a bunch of these in my pocket. So that's why I didn't use those. And then the 16550 is, again, the 18650. Actually, that would have worked out well. I don't have any. And so it's like, okay, well, what do I have? And I've already got a bunch of AA and AAA cells. So that's why I didn't go with one of those. Yeah. I'm still thinking about when I do one thought I have when I do the PCB. I might actually put this battery holder, depending on how big it actually is. It might go behind the displays, and then that way I'd only have like a little bit of circuit board on either side for the AT Mega and then the boost. But I haven't made that decision yet either. But yeah, it just came down to size. Size and availability. I didn't want to buy cells. Okay, so what we're going to try, KiCad Alphanumeric LED. So they're saying display. Because if I can at least get manage tables, old phone battery, Uh, mm, yeah, the only phones I have I use. I actually use my old cell phones. So I have one cell phone. This phone's dedicated to controlling my camera over Wi-Fi, and then I've got another one that controls the teleprompter when I use the teleprompter. And those are the only phones that I have. Although now I wish, man, I wish I had thought of that yesterday when I was at the surplus store. I could have picked up. I could have probably actually I could have picked up. Shoot, they probably have the cylinder cells. Yeah, I'm sure they can be, but I've got a bunch of double A's already. I don't really have a use for the 650s. That's why I don't have any. Um, they don't. I know everybody else on the internet loves them, and that's great. I I don't really care about them. Uh, let's see. Ah, that's not what I want. What about? Is there an LED library? I'm trying to see if there's a KiCad thing for this uh, LED for this LED display that I'm already going to use. I don't feel like redrawing 32 segment 7. I don't mind doing the footprint for the PCB because that's probably going to be harder to find. I just didn't want to draw a I didn't want to draw out a bummer. All right, we'll just do it the hard way. So for a long time, I've wanted to create a series and call it Breadboards and Beer. And so I feel like, because if I have to draw the boost circuit 2, this is going to get, all right, let's go library schematic editor. What I want to do here is my library. All right, and then I want a new symbol. Symbol name will be Alpha Jam. Sure, U1 is fine. No, I'm gonna call it D for diode. All right, zoom out, or don't zoom out. Oh my God. Reminds me of a bug in PowerPoint. Probably can't see that. Yeah, actually, that's something. Harvesting the cells out of a laptop battery pack. That's actually one thing I've been sort of keeping an eye out. I go to an electronics flea market. In fact, I'll go on Saturday, and I look for what looks like decent quality laptop cell batteries, but I haven't found any where I thought, yeah, I want the cells out of that. Yeah, breadboards and Guinness. Yeah, I don't know. The only reason I haven't done my breadboards and beer is I'm afraid I don't want the liability of, oh, you're doing electronics while drinking. Because, I mean, one thing is, I guess I could promote, like, when I do have a beer while working on electronics, I don't do anything with AC. That's just, no. I even if it's simple, like, oh, I know it's disconnected kind of things, I just, no, that's not an area I want to go. That's for safety reasons. And then when dealing with DC, It's more of a I just want to be. I don't want to mess something up. So normally what I try to do is like if I have to solder something and then wire something, I try to do all that, and then I leave the beer part to like either documenting, which makes for interesting documentation, or coding, which really helps because I don't like programming. And so that's sort of what I'm thinking towards. I just haven't quite figured it out yet. Okay, so here's what I'm looking at. Why'd you do that? Here's the display. I'm looking at how many pins there are because all I'm doing right now is drawing the schematic symbol. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this goes 17, 19, 20. All right. Well, that's simple enough. Looks like it's going to be 10 pins down each side. All right. So I'm going to hide that and then go back to drawing that. Yeah. At one point, I did think about doing like product reviews while drinking beer, and I sort of thought, I mean, that'd actually be a really nice casual way to do it. The problem is the companies that send me stuff, they wouldn't like it, and the ones that don't would probably get mad if I didn't like their product and then blame it on the activity, and I don't want to deal with that either. So why can't I copy? Oh, give me a break. Okay, so pin 1, this is pin 2. Pin 2 is T. Did I get that right? Nope. 2, right, input. Yeah, sure. Pin name 3 is S3. Okay, I'm already bored of this. This is the what? What the heck? I thought these were common anode. What? Oh. Oh my God. Yeah, 12-volt battery in the rain. I totally had a brain fart. I was thinking that I'm so used to when I put LEDs into a circuit, I always put the cathode down, and so I totally thought these were common cathode for a second, and I was going to be like, "You've got to be kidding me." Let's see, car 1. Pin number is 4, and that is a up. Okay. What? So input should be power input, and it's going to be down. All right. I'll just put this up here. Come on. And let's go ahead and do car 2, pin is 10, down power. Yeah, in terms of the breadboards and beer, I'm wondering what's the connection to electronics though? I mean, that's kind of a pointless, just because I want to kind of thing. 2, 3, 4, 5. 5 is decimal point 5. Actually, I'm going to put this down because I'm not connecting those in my design. Pin name 6 is G, pin number 6. So what I'm going to do right now is I'm going to just put these in numeric order. And then when I get to the PCB, I'm going to end up swapping the lines because I want the layout to be clean. Because I don't care what the outputs line up to. I'm just going to map them in software anyway. But to make sure I catch them all, I am going to do it this way. Let's see, 8 is... Pen name 8 is D8. Getting tagged by DC is different than AC. Yeah, totally. You know, I've heard people try to tell me that AC is safer to get shocked by because since there's a zero crossing, there's a split instant where you might be able to contract your muscle, which maybe that's true, maybe it's not. I don't really care. It still hurts. But I totally agree that AC versus DC, the sensation is definitely a different sensation. I feel like DC is more paralyzing. Maybe, I mean, it's been a while since I had a good shock from either, so I don't know. But I remember as a kid in high school, we used to try to shock ourselves and see who could tolerate the shock the longest. And so that was really brilliant. All right, 1, 2, 3, 4, 5. So I'm going to lose, so I'm going to have 9 per side. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there's this weird thing going on is I click and then it isn't until like it in the UI it deselects. So if I move my mouse, it moves along with it, and that's starting to really get on my nerves. All right, so 11, 12. Number 12 is N. How are we going to do this? Maybe about there. And then 13 is A. And pin name 14 is... I bet it's the other decimal point. No, that doesn't make sense. There is no 14? Am I missing something? All right. 15 is H. and 16, and you know, by doing this live stream where you see my screen the whole time, I think I'm actually getting things, even though I'm like chatting and doing stuff with the multimeter. I think I'm actually more productive this way because I'm not constantly going to Reddit and getting mad about something. Pen name 19 and 20. Okay, so maybe this isn't 10 on each side. But then why do they... Yeah, I wish I had these in the hand already. I'd feel a lot more comfortable. 20 is U. 19 is K. Okay, I see it now. 19 is K. Let's just move this so it's... Okay, so... All right, guys, I need you to help me out. So 4 and 10 are the common anodes. So I've got those. I'll change this name. I'm going to bring the diagram over so you can see it. All right. Okay, so here's my inputs, and here is the schematic. I need to take a quick breather. Can you guys look between the two and see if I missed anything? And then I'll be right back. Dr. Teddy. So when I was kind of mentioned this a minute ago. When I was in high school, my friend and I were in a vocational electronics class. It's actually where I started learning quite a bit about electronics formally. And we had varactors on our benches, and so we would have a contest to see who could hold the clips to the AC generator or transformer as we crank up the voltage. And I think I would let go around 30 or 40 volts, and my friend, I want to say he got up to at least 60 volts before he finally would give in. And you know, looking back, it's like that was probably one of the dumbest things we could possibly do, is to hold this AC thing that was basically just a varactor connected to AC main. So I mean, it could deliver 10, 15 amps easy. And yeah, it was really dumb. But I remember for me, what I remember what was weird is as you're holding this like AC signal or AC line, I could remember feeling like it was like I felt like the voltage was like creeping up my wrist. And so it'd get to be about here where it would finally start to almost hurt and I'd have to let go. But I could just feel, it was like you could just feel it. It was the weirdest thing. So, okay. So I go A, B, C, D, E, F, G, H, and I don't think there's an I or J, K, no L, M, N, no O, P, no Q, R, S, T, U. Okay, so I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 with, oh, you know what? I'll bet 14's missing so that, so you can key it and know which one is the, what orientation to put these in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yep. Yeah, that's probably what's going on. All right. So there is no 14. That's weird. Thanks, Andreas. Yeah, I'm thinking this thing doesn't have a pin 14, and it would probably make sense because it's probably so that it only orients in one direction. So all right, well, that solves that mystery. Okay, let's get that out of the way. All right, so let's see. So again, I'm not too worried about this symbol because I'm going to probably end up changing it anyway. Go right. Oh no. Oh no. Did I make these all power inputs? I hope not. No. Okay. All right. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it should come 1, 2, 3, 4, 5, 1, 2, 3. Oh, that's center. That looks pretty good. Thanks for the comments, guys. Appreciate it. I like making the videos. You know, I like doing it. It's fun for me. So I'm glad other people find them useful. You know, I started doing them a long time ago just because I was in a job where I traveled literally every week, which was cool. I've been to more countries than I can remember. Well, just more places in general than I can remember, really. However, it was really tough because I really wanted to be at home playing with circuits, and usually when I was home, I was taking care of home stuff. So I started doing the AddOhms videos because it was something I could edit and work on while I was traveling. Like, you know, I'd have to be home to shoot the camera stuff, but basically I would kind of plan out for a week or two what I wanted to shoot, get home, shoot it, and then that's spend the next couple of weeks editing and creating the animations. All right, so that's how that got started. All right, okay, so now when I go to save this, what the heck did it save it as? what is, oh man, I just saved it somewhere I didn't want. This isn't, I'm used to the package editor, and this isn't working the way, oh, that's why. Let me try this. Why isn't this? Okay. I'm going to do import. Okay, so that's where I wanted it. I want to delete it from here. Okay. Save. I can close this now. Yeah, sure. I don't. Where is my schematic? I'm going to add alpha. Awesome. And then that's going to go here. Now, the thing is, I should have actually separated those out a little more. Okay. So this is going to end up having, I'm going to end up with 6 of these symbols, but I want to break them out so that I can copy and paste those more easily. So and I'm not going to do the decimal point because that actually takes up too many. Thanks, Dr. Teddy. Yes, please hit the like, subscribe. Hey, based on my statistics, 80% of you are not subscribed to this channel. So I'm always surprised by that. And I've talked to a couple other people that do stuff on YouTube. And so one of the stats that YouTube tells us is on the percentage of viewers who are subscribers versus non-subscribers. And he's kind of in the same boat I am. We're both in the above 80% of our views come from non-subscribers. And so I always think that's interesting. You would just sort of think that most of your views would come from subscribers, right? It's like, why did you subscribe if you're not going to watch? And so, it's cool either way. I guess it means more people are discovering it, but it's like, not how I would have expected it to go. Okay, so I did name these out. So, man, did I mess that up almost? I would have noticed once I got to the PCB. Four, 3, 2, 1. Save that. Okay, so I'm just doing this for now. Because I don't know. So what I'm actually going to end up doing, so here's my plan right now is I'm going to break out this one, and then I'm going to copy and paste it 6 times. When I get over to the PCB design, I want to make this layout as clean as possible. So then I'll come back to the TLC and mess up the numbers here. Because, what I name the nodes doesn't really matter. But what I don't want to do is fix this on like 6 of these. So 2, come on. This repetitive stuff, this is where I think EDA tools really need to get more sophisticated. I mean, why am I having to do this? This is actually a feature I noticed when I looked at in the last week's live stream. I looked at Eagle 9, and they have a cool feature now where they call it breakout. You just right click on the chip and it does exactly what I'm doing now. It's not, I would say it's not perfect, because like in this case, I really need these labels to match up with something else, but it would still take or reduce so much work and effort that I normally have to do. But I feel like, so even KiCad, it's gotten, in terms of usability, I've been using it for almost 5 years now, on and off, and I'd say in the last 2 years it's been my primary tool. The usability has gotten better, but it's like it needs to get to the point where it's amazing to use. And so it's amazing from the perspective of the power and capability, but the usability is just, it's no different than most other ECAD tools. And where I'd like to draw the parallel is, I remember using DOS-based AutoCAD, and it was very much like Eagle in the sense that it was basically, yeah, it was graphical, but command driven or modal. And when I use like the modern equivalent, Fusion 360, it is a much more intuitive, better user experience. But when I look at electronic CAD tools, so KiCad, I guess Altium, although I don't have the thousands of dollars for a license, so I haven't really used it. KiCad, Eagle, OrCAD, whatever. They're still basically all the same in terms of usability. They don't do anything to really make your life easier or change the model in any way. And so I really feel like it's time that CAD tools or electronic CAD tools change. The paradigm that we're using now is just kind of outdated. In fact, I said I've been using KiCad 5 years. That's not true, because it's been 3 years. 3 years ago, I took a workshop, maybe 3.5 years. Anyway, so it wasn't 5. I'm mistaken. About 3 years ago, I took a KiCad workshop, and it was the first time, because I remember now, it was the first time where I was like, okay, now I get how to use it. And there was a guy in the class, and he's like, so let me get this straight. In 20 years, we still don't have auto routers that work, let alone anything else intelligent. I was like, yeah, you're right. CAD software hasn't changed, and electronic CAD software hasn't changed in 20 years. Anyway, I'm just ranting. So I just got Altium 18.1. All right. So is there something about Altium that you really like? And is there anything that you really dislike? And I'm only asking because my only experience through it is watching videos. I haven't personally used it. Okay. Now we need a transistor stage, and I'm going to use a 3904. What? Oh, come on. What? NPN. What's the, it was N3904. I should have a data sheet. Wait. I keep all my common stuff. It's funny. I'm a very, man, that is washed out. I'm a very electronic oriented person, and I really like keeping everything digital, except in the lab where I like to have paper copies of data sheets. So 2N22, 3906. Are you kidding me? I don't have a 3904 in here? WTF, mate? Well, okay. I'm going to use a... Man, it's still... I guess it's because it's white paper, so it's just washed out completely. So I just want it... I need it to make sure that I get the right pin out. I guess I'll just do a... So... Emitter... Nope, that's not right. That's not right. That's not right. That's not right. Emitter, nope. Emitter base collector. I was going to do 3904s, but hold please. I need to double check something. Oh man. I cannot believe I don't have the... Okay, I've got to fix that right now. I can't believe I don't have the 3904 data sheet. Wow, I wonder why that is. On semi, do file print from page 1, print. I save this to projects, data sheets, 2 and 3904. Okay, now you're just effing with me, aren't you? So why didn't that come up when I searched? Whatever. Whatever. Oh. On semi. We'll do that. 3904 flat side leads EBC. Yeah. Thank you. Uh-oh. That didn't work. You know what though? This page doesn't have any of the characteristics. Shoot. Okay, I print it again. From 1 to 2, two-sided print. That's going to be better. Yeah. 30. I wonder if I was... Okay, now it shows up. Was I doing 2904 earlier? No. Whatever. All right. What? Okay. You gotta be kidding me. So I just printed one page, and this is what happened. Where did all this come from? Like, did the printer really think, oh, I wonder if my rollers need to be cleaned. Okay, here's what I want to know. It's 2018. Why do printers still suck? I mean, okay. Now that's enough of that. All right. So what we got? So none of these look good. 3, 2, 1. That's what I want. If I search for, I can't find it. 2 in. Oh, okay. I'm going to do this. I'm going to put that one down. And then I didn't realize you meant search 2 in. Exosdel. What's the library that it's in? Because I don't have all of my models loaded. Is there one that's just called like transistor? Or I wonder if I turn on semi. Aren't they Fairchild now? Or is it the other way? Did Fairchild buy on? I always forget. 2N 3904. No. I ended up turning off all of my packages because one of the nightly builds for version 5 had a bug when loading, and so it wouldn't cache anything. And so it was just getting to be a real pain to... Okay. Well, I'm just going to go with my generic. That's going to be fine. And then in the value, I'm going to put 2N3904. All right, so we're going to move this over here. How do I want to do this? Can you do a flip? Mirror vertically? Yeah, it's going to work. All right, I'm going to move this up here, move this up here, move this up here. Yeah, weird. I wonder why I'm not finding mine. Oh well. But I think this is right because it's so flat side facing should be emitter base collector, right? So as long as I get the order right, I don't care if it's 1 2 3 or 1 2 3. As long as I get base correct, as long as base is pin 2 on the PCB, I can just flip the transistor. It's not a big deal. Okay. Do this guy, do this guy. Now, I need the bat because this is going to get power directly from the batteries. Wait a minute. Shoot. That's not going to work. That's not going to work. That makes for a low side switch, which is not what I want. Right? Because I've got... So I've got my battery, and then that's supposed to go into a transistor, and then that's going to go into my LED array, and these all go to ground. So I need to use a 39. I need to use a PNP. So if I do a P&P 2N 906. All right, P&P emitter base. Welcome back, Gustavo. Gustavo? Is that how you say your name? 1, 2, 3. Okay. Darlington, no. Okay. So I need a high side PNP switch, like Gustavo. Yeah. So orientation, flip horizontal. Well, orientation, flip vertical. I'll put that one here. Oh, you can't see that. And then copy and orientation, X and Y. Oh, I never knew that. All right, and then let's move this up here. Move this over here. Component 213906, and then move this over here. That goes up here. No. That looks better. Move this up here. What kind of blackboard do you use? Yeah, this isn't blackboard. This is just it's just black paper, and then I have silver markers. All right, so real quick, what I realized is, for some reason in my mind, I thought I could use a PNP transistor, but I can't, because then that would have made it a high side switch, which means if I put 5 volts here, then this would have been at about, I don't know, 2 volts. And so I guess I would have put 3 volts across the diode. Maybe it would have worked okay, but I'd rather do a high side switch so that my voltage drop goes from here. So this, turn it off, this will turn it on. Yeah, I did that backwards. Yep. And I'll turn it on. Okay, so. Oops. What base current do you need to drive those PNPs? That's a good question. I want at least 20 milliamps to flow through them. Let's just call it a beta of 100. So I'm getting tired, which is interesting. Or maybe I'm getting hungry. It's almost lunchtime for me. I want 20, 100. What am I thinking? So, no. I need 20 milliamps there, so I need 200 microamps to flow through the base. So I'm not going to bother calculating a resistor. Well, let's just, I guess I could do it real quick. Just to make sure, because I'm going to be using batteries that run 3 volts and then 0.7 for the diode drop, 200 microamps. So 10K, and if it's 2 volts, 0.7 minus, and then 200 e negative 6K. Oh, that's interesting. All right, so 4.7K, 2 volts, worst case. Okay. I'm actually glad I did that. I was going to put 10Ks there, but I think we're going to put, oh, you know what? I've got a boatload of 1K resistors. That'll be enough just to drive those things. Okay. So when I was in college, we had, I was a TA for a while, and the class I actually was a TA for was a analog class, which is interesting given that most of my career I've been doing digital. But our professor was an absolute character, and especially when we talked about MOSFETs, he would always talk about, you got to really turn that thing hard on. And I swear he didn't know what he was saying, but he just constantly would talk about, are you turning it hard on? Or are you turning it off? Because it needs to be hard on. And oh, it was amazing. Like, there was a very straight-laced couple. They were boyfriend, girlfriend in my class. Very conservative lifestyle. And even they could not stop from or hold back the laughter when he would say, make sure you turn that hard on. Still. Oh, Mr. Jacob, Professor Jacobs, I miss you, man. Hi, June. Welcome to the live stream. We are building a alphanumeric display. I'm at the point of designing the circuit for the displays right now. Oh my God, I totally forgot to do that. Wow. All right. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, this is going to be a mess. Shoot. Okay. I forgot I need a pin for every single transistor. Car 0. All right, I might have just simplified by not having the FTDI at all, because I think I'm going to need back pin 0 and 1. I saw you didn't draw a wire on Windows. This doesn't work. I need a small draw wire between the two components. Actually, yeah, actually, it normally does work, but now, but I usually do this. And one of the reasons I usually do that is just so I can name the node, but I'll go ahead and fix that now. All right, character 1, 2, so delete. Is this one configured? Nope. Delete, 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 delete. Move this over here, move this over here, move this over here, move this over here. Edit car 2, edit car 3, edit car 4, edit character 5. Yeah, you know what, in my mind, because these are 2 characters per package, in my head, I pictured this only needing 7 IO pins, but that's stupid because each character has its own control. 6, 7, 8, 9, 10, 11. Well, where am I going to get? Okay. Well, bummer. This just complicated things. This is another one of those. I'm probably going to end up changing these when I start doing the PCB layout because I want to make sure, I just want the lines to be nice and clean. I don't really care if they're in order. I'm going to change it all in software anyway. But to make sure I have the correct line or the correct number, I'll do it this way for now. Edit. Oh. Yeah, I think not. I'm actually thinking. I want to kind of think through this for in just a second. There is no point in having the serial port. All right, let me do a. I want to do a. Let's make a copy real quick. So let's just kill it. Because then I don't need to worry about having auto reset. And I don't need this. So that simplifies things. And then I can group these together a little bit better. Because I would like to keep, I mean, if I can keep things did I miss a number? Isn't I squared C a serial port? I squared C is a type of serial, but it's so there's UART, I squared C, and SPI, SPI available on the 328, but they all use different hardware pins and they all work differently. I squared C is a synchronous bus, SPI is a synchronous quasi bus. It's not really a bus, and then UART is asynchronous, and so. But they all use different pins, so I don't need serial support. What I'm thinking though is what I'd like to try to do, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Did I miss a number? Something's not, in my head, something doesn't seem right. Do you have a form where you can ask questions? You can, if you go to discuss.addohms.com, you can ask a question there. I prefer questions, especially project questions that come to me. I prefer them to be on a forum. It doesn't necessarily have to be mine, just because I think it's better to get a wider audience to try and help you with answering questions. Interesting. Yeah, okay, I did go through. It's not very active. I don't really push it very hard. I we just sort of ran out of time on it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I'm okay, just to try to put some color what I'm thinking really hard about. So even though in software I could create an array and jumble, so if in hardware all of these pins, all of these selects are jumbled up, I can create an array in software and fix them. But it's really nice when things stay on the same port. So like this is port C, and then these are on port D. And then that allows me to do like some bit manipulation things or port manipulation things on a bit level, which could be a performance later on in the software. And so I'm just thinking through if I'm missing something here. Since I'm going to have OSHPark do the boards, I'm okay with having a complex board layout. If I was going to try to mill this myself, then I would be a little bit more worried. So I'm just trying to think through where it makes sense to sort of throw some of these extra signals. Okay, I think we're gonna go with that. Okay, and the whole reason I did that is because I need to come here. How far over does that need to go? Okay, and then copy this one over here. All right. All right. That just looks a little messy. Anyone see anything I might have missed? I don't care about the decimal point. I'm not going to be using it, and I'm out of outputs anyway. Okay, let me save this. I'm going to do the same thing. I want to do this one, duplicate alpha. The reason I'm doing this duplicate is I'm going to duplicate this 6 times. And so if I get too far and realize I forgot to do something, then it might be easier just to roll back. And so I just want to have a copy before I do that, because I think now I can just do this. I'm going to run out of space. How do I change A4? What's bigger than A4? A4 isn't A4... That's 10 inches, isn't it? 8 inches? Yeah. So that's 8.5 by 11. Yeah. Okay. All right, that's going to help out. Wait, did I do it backwards? I thought A3 was smaller than A4. Is it? The numbers are bigger, James. Jeez. Okay. So, okay. Yeah, I did it backwards. I don't use, I mean, I have American papers or pages styles. Okay, I'm gonna have to go get beer. This is getting difficult. Okay, copy block. What? Oh. I know what. Okay. All right. Does KiCad support multiple schematic sheets? Yeah, it does. And I'm just going to admit I don't know how to use them, so I'm not. I agree when you can't get it to print on a normal printer. I'm not too concerned about it. I don't generally print my schematics anymore. What I'll end up printing out is the PCB design and then the BOM so that I can see what part values match up. But I'm not too worried about being able to print. I also don't mind scaling down in most cases. Okay. Okay. Let me come back to my list real quick. So now I've got that done. Got that done. Oh, I did do that earlier. Huh. Yeah, so whatever. All right. Oh, boost converter. All three of those we'll do together. Transistor test points. I don't really care about that. And then this. And okay. So let's kill this. Reset. We got that. The tag connector. You'll notice I haven't done the programming header yet. The reason why, I'm going to take a break in a minute. I'll show you what I'm going to do for that in a minute. I'm not worried about it. Okay. Okay. I need to go and refill my coffee. So I'm going to take a quick break and then I'm going to come back. When I come back, there's a major and minor thing that I need to do. The major thing is going to be I'm going to design the boost converter, which I should put design in quotes because what we're actually going to use is this design, which I worked out last night. So I'm going to design in that, and then I need to add the serial header, which I've got something special for that. And then actually, basically, the schematic will be done. So, okay, give me a minute. I'll give you something to talk about in the chat rooms while I go get some coffee. Okay, here's a good one. What is the best drink? Which is better, coffee or tea? Discuss. Yes, sorry about the loop. It's actually I've got about 2 minutes of it. I just haven't had time to. Every time I do a live stream, I say I'm going to combine it together, and I just haven't done it yet. Coffee to work tea Sundays. I think for me, I like coffee in the morning, and then I'll get like green tea for the afternoon, which is probably what I'll do today. So here's what I'm going to do. Check this thing out. It's called a Tag Connect, and let's see if they've got. I've had this for at least a year, maybe 2 years. But the idea is it's a very, very small and non-connector for in-circuit programming. So instead of doing a 6-pin header, you put in this very, very small connector, and then this just clips into the PCB. So I'm going to be using that on this design, mostly because I've never used it before. But I mean, just check this out. This is actually a good, I remember how I was going to show the comparison. Is if you just kind of look at it, I mean, its entire footprint is roughly the same size as 6-pin header, but it doesn't. You don't need to solder anything in, and you just clip this in and unclip it. So that, I think this is going to work out really well, and so I'm looking forward to designing that in for the first time. But I'm not worried about it at the moment. Because now it's the hard design. Sven, have you used this Tag Connect? Because I'd like to see how well it works. Well, not only do I like to see, I'm going to see. Okay, I keep procrastinating. Okay, so I did a couple of videos on linear and switching voltage regulators, and in the switching, I teased maybe showing how to do a design, and people comment, hey, show how to do a design with a transistor. And the thing is, I haven't designed a switching power supply with a transistor, an inductor, and capacitor, discrete components, since college. And what's even worse is I haven't designed one with a switching controller from scratch for over a decade, because TI's Webbench software just works really well. You put in your voltage range on the input, what you want on the output, and then it gives you the option of footprint or price or efficiency. And so when I did this design last night, so I need something that can work between 2 and 3 volts, because I'm using nickel metal hydride batteries. So I'm guessing they'll drop down to about 2. Fully charged, they'll be barely 3 volts. And on the output, I'm going to go ahead and go to 5 volts because I just wanted a decent amount of headroom, and the current to be 50 milliamps. So I put that in, and then it gave me an option which was 95% efficient, which would have been fantastic for battery life, but it was $3 and it was relatively big. So I picked this design, which is relatively small and is going to be on the order of $1 at lower quantities. This says 65 cents, but that's at quantities of 1,000, and I'm not building that many. So what's cool is I'm going to capture this schematic into KiCad. Thank you, Dr. Teddy. I will. I appreciate your marketing efforts. I will award you 1,000 internet points, since that's all I can give. Okay, so I'm going to capture this schematic into KiCad. So I'm going to throw it on the other side of my screen so that I can work with it. Even though I've drawn something like this a couple of times, I don't know if I have this regulator in KiCad already. So TPS 6104 VNS out. What? Ground. That can't be right. Why would that be ground? What's its pinout? I need this. And I want to compare it to this one. So pin 1 is switch, 2 is ground, 3 is feedback, 4 is, 3 is enable, 4, 5. Did I not load Texas? Come on. Oh man, I don't want to. Press the connector while they're uploading the firmware. Yeah, I'm okay with having to hold the thing while doing the firmware. That I'd prefer if it stayed in place, but when I was thinking about designing my own like pogo style thing anyway, I figured I'd have to hold it. But I think not having to put a connector down and not have the connector, because it's going to end up probably facing me, would hurt. All right. Okay. We got to go in the library editor. I did not want to do this again. I don't like creating my own. I guess I could go look at Snapcat and see if she's got it. How about a TPS 61070? Yeah, that's what I'm looking for. TSOP 2003. Switch out. Really? That's not a good way to do the symbol. Then I got to do out. Okay, fine. My libraries. My library. Add part. Oh, that's not what I wanted. Okay. New part. Symbol name. TPS 61070. Okay, here's a question for you guys in chat. Who makes better power ICs, linear or TI? I had to think for a second because it's linear and analog that merged. All right, so I'm going to do this. What I want over here is this. So we call this one VBAT. Pin number is 6. Left power input. Right. Okay. Oh, it's getting on my nerves. All right, let's do another one of these. Have you tried the? Oh, Gustavo. By the way, I just put the stickers I told you about on Twitter. I just remembered. I put them in the mail yesterday, so you should be getting those probably in another week or so. I didn't forget about you. I was waiting until I had a bunch of stuff to go to the post office. So I want to tell you about that. Have I tried the DigiKey KiCad library? No, not yet. That would have actually, I'll bet that would have actually been a good idea. I just haven't. And I mean, this is kind of one of these projects or designs that I just sort of, yesterday I was just thinking, hey, Maker Faire is coming, so I want a badge to wear. And so like I said earlier on, part of the reason I'm even doing it in KiCad, and this would have been a really good chance to try out Eagle just to see what's new with it. But I want it to do what I know and stick with what I know to do. Stick with what I know to do. And the whole reason I'm telling that story is my libraries for KiCad are totally messed up. I have 3 different versions of KiCad installed. And that's why I keep changing the name KiCad and KiCad, because I've got multiple versions. I've got 3 different versions installed, and the libraries are like spread all over the place on my computer. And so part of the reason I haven't tried the DigiKey one yet is because I need to clean that up before I dive into it. Question I'd come back to you is, have you used the DigiKey KiCad library? Because I'm curious how robust it is. All right, so feedback, V out, switch, VBAT enable, and ground. All right. And by the way, on the stickers, I meant to put a note in there and I forgot. I'm sending you a couple of my stickers, and then I have like a whole box that I collect when I go to like meetups or I meet with companies in the Bay Area, since I'm in Silicon Valley. And so I'm throwing in a couple of stickers I've just gathered that I have extras of. So I thought you might like those as well. It's not a whole lot, just a couple extras. All right. All right. I don't know why I made a big deal about drawing this. I mean, it took me, what, 4 minutes? All right, save that. Why isn't it on here? So TPS 61070, VBAT, enable, ground, feedback, out, and switch. Okay. Now we will come back into here. I want my TPS reports from Bill Lumberg. I'm going to do this over here. This is all boring stuff. Move this over here. Battery. Battery, I still need to figure out how I'm going to do that. I think I'm going to draw that in Illustrator. I'm not going to make a package for it. I guess I'm going to have to. All right. Now, so how long has Infinity War been out? Can we talk about that yet? Okay, I need an inductor. 2 resistors are going to go over here. I need my capacitors. One reason I liked this this design is that the input and output capacitors were the same, which then I can use as decoupling caps for the 2 ICs, because they're going to be high value ceramics, which are going to have a really low ESR. So they'll be pretty decent at low or high frequency decoupling. I was actually surprised. I actually looked on DigiKey last night to make sure I could find 10 microfarad capacitors. There is a worldwide shortage on, that's the wrong package. That is the wrong one, James. Where is my library? This one. All right. So anyway, there's a shortage on ceramic capacitors, and it's probably going to continue through the end of this year. So some of you may or may not know, I used to work for a capacitor company, and I used to do seminars on them. In fact, I've got a link somewhere on the YouTube or AddOhms YouTube channel to the videos I made for that company. Here's a quiz for you. So ceramic capacitors effectively start out as powder and then go through a bunch of processing steps to create the actual chip capacitor. So from start to finish, how long do you think it takes for a single capacitor to be made? Is it hours, days, weeks, or months? And then after you guys give me a couple guesses, I'll kind of walk through what the process is for a ceramic. Okay, and then bring this guy over here. Enable is just going to go right up here. VBAT is going to come over here. And we'll do this. Weeks. Okay. 1 vote for weeks. Now, this is actually going to be, I'm just going to say V5 out, and I'll explain why I'm doing that in a minute. My instinct says hours, but probably days. Yeah, so for modern BME, base metal electrodes, so that's the most common type. They're made with nickel electrodes. They take about 3 weeks, 21 days from start to finish to be completed. They'll spend at least 2 weeks in a oven process where they're baked multiple times, and so that's the bulk of the manufacturing time. The rest, the front end, you start with powders, you mix that into a slurry, spills it out onto a plastic sheet, then you stamp the electrode patterns, cut them up, stack. That process, you know, that might be a day or two of processing. They go in the ovens for a couple of weeks, and then they come out for testing, corner rounding, stuff like that. And so it takes about 3 weeks. In terms of aging process, ceramics don't go through an aging process. They get baked multiple times. One of the interesting things about modern ceramics is that, so you bake them in an oven, I forgot the actual temperature. It's on the order of like 1,000 to 2,000 degrees. And what ends up happening is the dielectric layer is barium titanate, and the nickel will actually leach out oxygen from the barium titanate and form an oxidation layer inside the capacitor. And so what ends up happening is you fire it, and then you go through this process that they call reox, where it actually tries to reoxidize the dielectric layer, and then you fire it again, then you reox, then fire it again and reox, and that takes a while. But ceramics themselves don't get aged. Electrolytic capacitors, so tantalum, niobium, aluminum, those do have aging processes associated with them, and that's because you're trying to fix faults in the dielectric layer that happen during the manufacturing process. And depending on the size of the cap, and the technology, that can be seconds to days. Film capacitors they don't get aged, but they do get proofed, which is they just, like, if it's rated for 100 volts, they'll get hit with 500 volts and see what breaks down. Yeah, ceramic does need a, well, yeah, I mean, any of these caps, they have to be cooled especially. The really cool one is tantalum. When tantalum anodes come out of the oven, so those get fired around 2000 degrees. So there's what they call high charge, and basically it's smaller tantalum particles. And the great thing about the small particle is you get bigger surface area. More surface area is why you get really, really high capacitance out of a very, very small cap. But what can actually happen is they have to be very careful to reintroduce oxygen to the tantalums, because they get fired in a non-oxygen atmosphere. And so when oxygen gets introduced to them, the tantalum starts to oxidize. Well, the oxidation process, it's just a surface level oxidation, just like aluminum. It oxidizes almost as fast as like aluminum does, but it creates heat. And so you get this ridiculous amount of surface area creating heat all at once. And so I remember walking around the factory floor or the R&D factory, and you could actually see holes in the ground, because what would happen is anodes would come out of the oven and they hadn't figured out the passivation process for that particular recipe, and they would literally just burn themselves up and put holes in the ground. And so I always thought that was just kind of cool. I mean, the thing that gets me with capacitors is they have as much technology as an integrated circuit, and they're sold for 1/10 or 100th of the cost. Tantalum capacitors, there's like 22 processing steps. Ceramic, I would say there's on the order of 14 or 15 processing steps. I mean, it's not like, we used to do these factory tours, and I remember one time this guy came up to me and he said, "Hey, okay, this is great. Can you just point to which machine makes the capacitor?" And it's like, yeah, you get this massive infrastructure to make capacitors, and there isn't a single machine, which is also why there's a shortage on ceramics right now. Electronics are at an all-time high in terms of production, and everybody wants ceramics, so they're getting used up. All right, now I need to add some values. So this is going to be 10 microfarads. This is 10 microfarads. This one is 180K. 180K. This is 1.62 meg, I think. Nope, that was wrong. 1.62. And this is 180K. That's 10. Got that. And then this is 10 microhenry. Yeah, cheaper than the process makes them sound, absolutely. I mean, the thing with ceramics, though, is, yeah, it takes 3 weeks to build them, or make them. But, like, you figure, like, an 0402 or 0603, you're doing thousands, tens of thousands per batch. And, that still only takes up a relatively small space. So, company I worked at, we were probably number 5, I'd say between 4 and 6 in terms of size of capacitor companies in the world, which was a difficult thing to rate because most other companies our size did a lot of other products. So it's hard to figure out who exactly was the right size. So that's why I say top 4 or 5 companies within the top 5. And we calculated, we ship 36 billion capacitors a year, which when you back it out, comes down to 1,000 per minute, I think, or was it second? I forgot. It's got to be minute, I think. But you think about 36 billion capacitors, and the really scary thing is every one of them were tested at least twice. Now, most of them got tested 5 to 6 times, but every single capacitor we shipped was at least Key parameters were measured at least once, if not multiple times, and then capacitance was always measured twice. Once to bend them into the 5, 10, 20%, and then once right before they go into their reels or final packaging. But 36 billion capacitors measured twice. I mean, that's 72 billion measurements. It just boggled my mind we're able to do it. Okay, so here's my switching, my boost converter. So it'll take 2 to 3 volts on the input, put out 5 volts. This is going to drive the logic. This is for the 18 mega and for the TLC driver. The LEDs are going to be driven directly from the battery. There's no point in boosting up the voltage. In fact, yeah, there's just no point. I mean, their forward voltage is only 1.6 volts anyway. What I want to do, though, is talk, how did I come up with all these numbers? So as I mentioned, I just used TI's Webbench software, and it basically gave me, I told it my input, my output, my current, selected a few other things. Now, the one thing I did have to do, though, is when I look at the parts that it suggested on the, so the, that's not going to work. The capacitors it suggested weren't available, so I had to swap those out. And then on like the resistors, it always picks these really small value, like 0603 and 0402. And even though I'm going to use OSHPark to make the PCB, I'm going to have to hand place these parts. And while I can do 0603, 0402 is just a pain to deal with. And so I try to keep everything 0805s. And so I actually did this. I went through and said, okay, here's the parts that TI recommended. Let's see if I can zoom this in. Here's the parts that TI recommended. And then I went and found my own. Now, if you look up this part number, you'll figure out who I used to work for, because I almost always buy their components just because I know the part numbers. The inductor I left the same. It's available. The resistors, nothing special there. I just needed 0805s and then the actual part. Now here's what's cool about Webbench. And so let me see if this is going to work. And if not, I'll just redraw this really quick. It may take up to 30 seconds. Now, what I don't like about Webbench is it's still a Flash-based program, but they have an HTML5 version of it. And so it actually does, the HTML5 actually works pretty good. I don't care, can't see what I'm typing. See if it's going to work or not. Okay, I'm just going to walk through what I did last night. So check this out. This is, and in fact, I am going to do a video on switch converters, like a full, like my normal tutorial. But the thing is I'm going to use Webbench to do it. I'm not designing it with a discrete transistor and capacitor and inductor. There's no reason to. I will get into, in that video, I'll get into the calculation on selecting the inductor and the capacitor, even for a switch controller, but I'm not building one from scratch. So anyway, here's how Webbench works. You say, okay, what's the range of voltage that you're going to have on your input side? So in this case, I'm using a battery, and like I said, I'm expecting it to fluctuate between 2 and 3 volts. I want 5 volts of output, and then I'm just estimating I need about 50 milliamps of current in order to drive my 18 mega and my TLC. Now I do think that that's actually a high estimation. I don't think they're going to draw that much, but I figured that's a good number. Ambient temperature, we'll leave it at room temperature, and then say show recommendations. So then, I just love this. This is just brilliant. it gives you, I thought it was 3, I guess it's 4 options. Do you want higher efficiency, something that's smaller, something that's cheaper, or something that uses the fewest amount of components? And so this is a pretty simple design. So 6 versus 5, it's like, who cares? You know, it's basically the same. But look at this. I mean, this design over here has an efficiency of 95%. And so, you know, if I was producing a product, I would probably be looking very close at this design, because that's great for a battery. The rest of these are in the 75 to 80%. I guess that one's 85. That's actually that's not the one I ended up with. Damn, it is 1,000 per second. Holy cow. Okay. Anyway, so efficiency is really good. And then the size. So that's another reason I didn't want this high efficiency, is that its footprint is significantly larger than the others. Now, that's debatable because I ended up changing the part sizes for a couple of these anyway, so that's irrelevant. But check this out. I mean, this design, $3.60. Well, I can buy a couple extra batteries for that same amount of cost difference between this design and this design. So in my case, it's like, all right, I'd rather go with the cheaper design than the more efficient design. Also, it has fewer parts, which is going to make my design much easier. Now, what I did know is when I looked at this component, this comes in like a ball grid package, and I don't know that I can solder that with my oven. So if I, no. I need to show more solutions. So then you can start to say, okay, well, I'm familiar with this series of parts, and so I want this design. Okay, now, normally when I use WebBench, the PCB layout that it recommends is like a really good recommendation. I don't know what the hell is going on with this one, and I'll show you this in more detail in just a second. But check this out. This is what one of the reasons, so one reason I went with this component is because I know I can put the package through my reflow process. But I really liked this efficiency curve. So here it's showing me for VN at the low, the high, and the middle, what's going to be the converter's efficiency based on the amount of current it's outputting. So I said I want it 50 milliamps, and so that's where it's, for the most part, going to be its most efficient. And when the battery's brand new, if I'm at fully loaded, it's going to be 90% efficient. But I think worst case is it's actually going to be more like 10 to 15 milliamps most of the time. So if I look at 15 milliamps, I can see that for across the battery's range, the converter is going to be about 80% efficient most of the time. And so even if you get down here, it's like, you got to really get below 10 milliamps, which I know I'm going to be above 10. I mean, 75% is not bad. So I really like this. What I like about WebBench is it does something like this. Check this graph out. Let me see if it was in this one or if it might have been in a different one. Yeah, check this graph out. So here's what I want to know. And I'm not trying to knock. I'm sure somebody worked really hard to do this. And I just want to know, who in the hell is this graphic useful for? Look at this line. It's like... It's like, that doesn't make sense. You can't do anything with that. So, but that's cool. TI's got WebBench. I love WebBench. It just makes the design easy. Now, as I said, the PCB layout made no sense to me. I mean, not no sense, but they've got really big pads, really big floods. And I'm not sure why, because especially like this design, it's only a few milliamps. It's not like any of these parts are going to get hot, so you don't need the copper for heat sinking. So what I found interesting is this is what WebBench, this is what WebBench recommended. And over here is what the datasheet recommends, which to me is, I see the pattern here, but this one makes a lot more sense to me. So you have your chip, and then you do a flood for ground, and a flood for one side of the switch, as well as a flood for the other side of the switch. tie that to a via to the bottom layer, and then that bottom layer connects to ground. Flood out ground, connect that, have your resistors come through, the output capacitors, and then V out. So to me, this just is a really clean, easy layout. I don't understand why this one, I see these elements, but this just looks like a mess to me. I almost think there must have been like a mistake in the script that generates this, because it just doesn't look right. So anyway, I'll be drawing this later. Fun. Okay, so let's see. What do I want to do now? I do want to come back to my KiCad, and I want to add manufacturer part number. Let's just throw these in real quick. Okay, I don't know why you're complaining about that all of a sudden. Grab this capacitor, NPN, put that in, edit, NPN. Come back to do those in just a second, because I want to come over here and do the same thing. NPN, and then NPN. All right. And then for my resistor, 180K, that's that. Okay. And then everything else is mostly I just did that because I just wanted I wanted that part of the design to have my part numbers burned in, so when I export a BOM, everything is where I expect it. All right, and then the resistors. Thing is, with the capacitors, I think I already have them. The resistors I need to buy, because with all these with these designs, I always end up with weird resistor values, so we'll need to do that. That's not. All right. Okay, so that's done. So boost converter, okay, power switch and solder jumpers. So I've got a single pole, yep, one of these. Okay, and jumper. No. Okay, so I need 1, 2, 3. What I'm trying to design in, okay, so so the switch actually goes over here, and I should have actually, the COM is going to be VBAT, and then this is going to be VN. Wait, what I'm trying to design, I want to be able to disable the switch converter in case I screw it up. And so let's think through this for just a second. So this definitely, All right. So I've got a switch already in mind, and it's a double throw. So one side will just do nothing. So in fact, we'll just connect it to ground. No, we won't. We'll just leave it floating. VN. So I want VN to be able to go to the switch converter. Or directly to VCC. So what I'm trying to do here is these are going to be, I'll be able to solder a jumper onto these just to make it, oops, to make the connection. So if I said be into here, let's see. All right. VN. Okay, so I can do that. The other thing I want is VN to go straight to VCC. So I can drive directly. And then V out. Okay, now I remember what I was. What? Okay. All right. This is overly complicated, but hey, I like to make things overly complicated. Let me rubber ducky this with you. So what I'm trying to do is I've got my battery. I'm going to go into a switch, which I actually had it sitting over here a minute ago. And so the switch has 3 contacts, common middle, and it can go between one or the other. This says normally closed, normally open. Don't care. So when it's down here, it'll be off, come up to here, then VN. These are going to be solder jumpers. So when I make the board, I'll have to solder these connections. So initially, I'll solder the supply, the switching supply in. So VN will go through here, and then I'll make this connection so that goes to VCC. If this circuit doesn't work, then I can kill this, solder that, and have a direct. Okay, that's what I wanted. I wanted the flexibility to take this VCC or this boost converter out, just in case I do something wrong with the design. Because I think without it, my circuit will work fine. It just, I won't get as much energy out of the batteries. So, but I'd prefer to have it. So we'll go with that. Okay. Come back to solder jumpers, power switch. All right, programming header. So these guys, I think, have KiCad tag connect. Tag connect. So how do I get it? All I want is just let me download it. By downloading the following file, the user agrees to take full responsibility for checking the suitability of the imported footprint. I don't think I'm going to take responsibility for anything. That's just not my style. Oh, wow. Okay, so what do we got going on here? KiCad another. That's not giving me a whole lot of confidence. What is all of this? Okay. Balls. Schematic drill. Okay, so that doesn't really help me. I wonder, is this a... I wonder if KiCad will recognize okay, so I keep a folder of downloaded libraries. Guess where I put into there? So let's go manage library table, append library, nope. Browse library, I want this one, open that, okay, add tag, okay, which one do I have? I have 2030 IDC. This is MPC or MCP. So that is not what I want. That's a bummer. All right, so that one doesn't work. What is this one? What is EMP, I wonder? Okay. New folder tag. Let's just do this. Browse. Drag this guy in. I don't know what I just did. Drag this guy in. What's this look like? All right. History program foot. I like that name. That's clear. Nope. All right. Okay, so the tag connect is worthless if you use KiCad. Shoot. So there's this mod, which I guess is all right, let's just do this real quick. Let's come back to the footprint editor. I want to see what's in this mod file, because maybe I can just use a standard header and tie the footprint together. So I want to load from a file this one. Okay, so it won't load that. Perfect. Yeah, I was really afraid that that was going to just work. Set active library, wizard, file on my computer. This is one of the things that irritate me about KiCad is why does the schematic editor use the OS file browser, but the PCB and footprint editor don't? I mean, I don't get why this has to be its own thing. I mean, seriously, if you're writing software and you're creating a file browser from scratch, you're doing something wrong. Dropbox. Oh, crap. I didn't put it in there yet. Download it. Wait, .mods. Shoot. Yeah. For some reason, .mods to me aren't. Whatever. All right. Now I should be able to load in here. MCP. So okay. Okay. I don't get why can't I open footprint viewer. No, I want to open load from current library. I don't know what, shoot, what was the difference between these two? So looking at it, I think it's FP. So we're going to file load from current library, MCP, list all, MCP, FP, okay. And now I'm going to do a print. Are you kidding me? You can't print? Oh, come on. Well, what's the likelihood that this is right? Okay. Okay, let's try this. Let's just load PCB new. Which one is it? And add a part. Yep. Okay. File print. Basically, I want to print this out so I can make sure that it's a one-to-one. So, oh man, why did I have any of these selected? Accurate one-to-one, pin size, 0.1 millimeter, single page, one layer, single page, print. There's a bug, at least in KiCad 4, where it would do more than one page, file print, scale 100%. It's going to print outside the bounds. That's okay. All right, if this works, then okay, so what I can do is, so now what we can do is assume it's going to work. Welcome back, Dr. Teddy. I'm surprised my internet connection's held up. Actually, 25 frames per second? That's weird. Wonder 2025. Okay. Well, I think I'm glad I printed this out, because I don't think this footprint is even close to the one I have. So it means I'm gonna have to build my own, I guess, which I just can't believe somebody else hasn't already done this. Yeah, these don't, it doesn't line up at all. It's a real bummer. Is there like a different package? Did I get the wrong one? Is that what happened? So I have the 2030 IDC, this one. Okay, NL is for no legs. Yeah, okay. What? So I've got this is the one I have, the 2030 IDC, and mine has legs. So that's definitely the right one. Where's the data sheet? Okay. So what I wanted to look at, do they have, what's the data sheet for the MPC, MCP? So this is the one that but no data sheet on the pinout. That's cute. Does anybody ever like look at their own website and think, can anyone use this? Okay, so let's try TC 2030 IDC KiCad. Oh. Okay. All right. I don't know who this is, but thank you. All right. I guess I just need to get, if I get this done, then the schematic's done, and then I can go get lunch. I just want to get it done. I want to be finished. Lib DCM. What did I just do? I wasn't paying attention. Yep. Thanks, Local. That's the one I found just now. So we're going to try adding that one real quick. do footprint wizard, files on my computer. Same complaint from a minute ago, because why do I have to do this? This is dumb, 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 dumb. Use the OSX file manager so I can just drag and drop. And KiCad just crashed. Okay, so that looks okay. KiCad connect. Let's see. When you say connect, did you mean the connector library? Okay. I'm okay with that. What are they called? Is it called tag? That'd be nice. Ooh, no, that's JTag. That's not what I want. Connector, or is it connect? What else could it be called? TC20? No. All right. Manage foot. Okay, this one, let's remove that. Is there one just called connect? Okay. All right. Okay. What I'm going to try for the moment is, let's do this first. And this would give me confidence, because I'm just afraid it's going to crash again. I wonder what they called it. Okay, maybe he didn't have a symbol for it. All right. Ah, damn it. Well, okay. If this fits, I can just modify it and add the holes for the legs. It's going to do a print. Yeah, actually, I think that's what I'm going to do. And in fact, I've got a ICSP header foot or a symbol, which is, I guess, what this guy probably meant for this to be done, to do it that way. Thing is, mine has the legs. I can't believe he doesn't have a, well, I guess it's his own library, so. I could just order the one without it. Yeah, I didn't see in, so if I do TC, yeah, I don't know if I just didn't download it or what. All right, let's at least do this, because our ISP6, this one up here. So copy VCC, copy ground. Copy MOIS, copy MOISO, clock, reset. Okay. Oh, I see what you're saying. Oh, you know what? That's probably why I'm not getting it. Oh. Okay, hold on. Okay, let me save this because I needed that anyway. Footprint wizard, footprint table. Yeah, that's why I'm not getting it, because I don't have I don't have it loaded. What am I looking for? Users, James. I hope it's in my version, because this computer doesn't have yes. Nope. No, I don't have it. All right. If I just do IDC, no legs. Yeah, it's not in mine. Okay. I'll go download the new version of the library. Maybe mine's just out of date, but that's what I need. Okay. I'm not worried about it at the moment. I'm worried about it after lunch. So got my AVR, got its programming header, mounting holes. I don't need this stuff. My TLC, my segment displays. I'm going to have to draw this next, and then this guy, which is the power supply. So I was hoping to be done at this point, but nope. Okay. EXO, thanks for the comments on the header. I think I need to download. So I think I need to download the latest version of the library. Yeah, I'm using the nightly build 4.5, pre-5, and the GitHub repository I have is from 4, because this computer doesn't have the repository for 5. Long story, but I'll get the updated version, see if it's in there. Worst case, I'll just add the holes myself. I mean, that's easy enough. So, all right, I'm going to wrap this one up. I am probably going to stream later on today because I do want to get the circuit board done, but I need to get something to eat and do a couple other things. So thanks for everybody that joined. Thanks for those that stuck around, and definitely will be doing a little bit more of the stream for this design because, hey, this is kind of fun. I'm James, Bald Engineer. Find me at baldengineer.com. And then you can find AddOhms just about everywhere by typing in AddOhms. Thanks, everybody.